Here are my audience members. Okay. Hi guys, my name is Sadhana Kallampalli Ilam and I'm a sophomore studying computer science at Purdue University. On campus, I'm involved in research with AI in the musical field, as well as AI for enterprise AI adoption. Alright, so today what I'm going to be discussing is why explainability in AI matters. So how many of you use ChatGPT in your everyday lives? Yeah, I'll admit it too. I use ChatGPT a lot as a study tool for many different purposes, for helping me write emails, things like that. But while you use ChatGPT, you guys might also have noticed that a lot of times it hallucinates or generates inaccurate answers to your questions, starts making up its own things, and we have no idea why, right? Because we don't know what the model is doing, how it's making these decisions, how it's telling us what it's telling us. We have no idea what's going on behind the scenes. So that's what explainability covers, is understanding like what's going on behind these black box AI models. So I'll just clarify a few definitions before I get started. The first one is XAI. So explainability in AI has become a whole field now, and it's called XAI. And XAI is basically the study of different methods that make the whole decision-making processes of AI systems transparent and understandable to humans. And then I'll also talk about the different types of AI. So the first type is traditional AI models, where basically like you feed it images of cats and dogs, and then you give it an image and it's able to classify it based on its training, right? And the second type is Gen AI. Gen AI is a class of AI models that is designed to create new content. So it creates new images, new audio, right? New music, code, videos, things like that. So that's the new form of AI that's been evolving, and I'll be talking about that today as well. All right. So let me talk about why explainability is important in the first place. As you can see here, different stakeholders need tailored AI explanations to ensure alignment, compliance, and usability. So explainability is important to many different people. So according to McKinsey's 2024 State of AI report, executive decision makers, AI governance leaders, affected users, business users, regulators, auditors, developers, all of these people require explainability within their AI functions. So AI regulators need it for being able to certify AI systems. AI developers need it to be able to debug and improve AI systems. If you don't know what's wrong, how the model works, how are you going to be able to debug it? So that's the basic idea there. And then AI managers need to be able to assure the compliance of AI systems in the organization. AI users like us need to be able to validate the reasoning with our own reasoning. And then individuals who are generally affected by AI-based decisions also must be able to evaluate the fairness of these decisions. So that's what this model illustrates. Now that we understand the importance of XAI and how many people it impacts, let's move into understanding what the main issue is. So the main issue is that many organizations haven't yet integrated explainability into their AI systems. So in this image, this was by the McKinsey survey that I referred to earlier. This is the different priorities that companies have in terms of and what they're working to mitigate. So as you can see here, explainability is one of their low priorities compared to all these other issues. Explainability is kind of their second priority, something that most companies aren't working to mitigate currently. So most of them lag behind when it comes to human ethics and sort of explainability issues, which is the main issue here. According to IBM's 2023 survey, 85% of IT professionals strongly or somewhat agree that explainability in AI is really important, but well under half of these companies actually report taking steps toward trustworthy AI. So that's the major issue here, is the gap between intent versus actual implementation. So moving on. Here's the solution. The main reason for this issue is a lack of structured frameworks for being able to systematically integrate explainable AI into these organizations. So there's kind of not a structured way of going about it, and a lot of studies have proposed frameworks for this, which I will be presenting to you now. Also, a lot of these organizations are struggling to scale AI in general, so there are many different challenges that they're facing, which is why explainability is taking a second seat. So let me first start by explaining this first figure here. So this was presented in the study by Arun Das and Paul Rack, who are senior IEEE publishers or authors. So here this image shows the concept of locally explainable models in machine learning, especially for complex neural networks. So what the basic idea here is, this is the input. So we pass in an input to our model, And here's the black box model. It's too hard and complicated for us as humans to understand how the machine is coming up with a decision, and it generates an output. And what this locally explainable model does is it generates an explanation after the output is generated. It generates an explanation to explain how this input led to this prediction. So it's kind of done after the entire classification process, mainly because for us it's hard to understand how the machine makes these decisions. It's not always like human reasons that we have. And here I'll go into greater depth. This study by Zhou et al. Explores this in greater depth, and it explores explainability at different stages of the machine learning pipeline. Okay, so first of all, the pre-modeling explainability stage. Here, the main intent is to understand the data before building any model. So that's done through data analysis, data summarization, data transformation to make sure that there's interpretability within the data itself. This is before it's put into the model, right? The next stage here is the interpretable model. So there's many different types of models. Some are clearly easily interpretable and they're inherently interpretable. These include models like decision trees, linear regression models. All of these are inherently interpretable and we can sort of better understand them versus these black box models, right? This is the second type. It's called a hybrid interpretable model. So here, since it is a black box model, like what I talked about here, we also have to add an extra explanation, an extra mechanism for the explanation, which is done by decision trees, fuzzy models, and canons. So for black box models, the best approach to addressing that is by supplementing it with one of these sort of simple models that are more inherently understandable, right? And lastly, we have the post-modeling explainability, which I described earlier, which is being able to explain how this input generated the output after the output has been generated. So that's the third stage. All right, so that's a pretty clear understanding of how these different techniques, right, within explainable AI function. There have also been multiple other frameworks that have been proposed to evaluate XAI. Love et al. Proposed a CCPO framework, which is basically content, context, process, and outcome framework, which is basically a way for organizations to be able to evaluate how they integrate explainable AI into their services. Similarly, Alavizos et al. Also highlight 9 key dimensions, which I won't be getting into, but they basically explore how inclusivity can be integrated into these explainable AI models. And so what I'm trying to get at overall here is that the main cause for this issue is so as AI evolves, explainability becomes a need for many stakeholders, as we noticed here. And while organizations are currently lagging behind in being able to integrate XAI into their workforces, there are structured frameworks and specific Gen AI techniques which they can employ to be able to better get ahead on that and provide a solution that benefits both the developers, end users, and multiple other stakeholders that are impacted. Thank you for listening. Thank you.